The aerogels are world record-breaking materials. You can find them in the Guinness Book, and they exhibit very high porosity, very small pores, and low densities. And if you do the preparation the right way, now you can produce superinsulation materials. And the beauty is the thermal insulation performance is better than air, even though they just contain air.
Wow. Hey everyone, welcome to the It's a Material World podcast. I'm your host, Puneeth. I have my co-host, David, here. David, you're not looking too hot. How's it going?
Well, thanks for telling everybody that. I am recovering from COVID, so it's been a little bit of a struggle recently, but it was excited for today's conversation, of course. As Puneeth told me not to say, but since you said that, I could have used some super insulation for my fever, which is a really bad joke to say that we're going to talk about aerogels today and their unique property of super insulation and their uses in industry. And so with that, Puneeth, what were you excited about the conversation today?
Yeah, it was just really cool to hear about kind of the super insulation properties of aerogel, right? And how it's made, what the structure is like. Essentially, as you said in the episode, it's like 99+% air, right? But it has better properties than air itself, which was just very like mind-boggling to think about. And then really like I think usually how these episodes go is like I try to ask the like application-based questions, like really dive into the why and the potential impact it makes, and then I feel like you really get into the technical aspects. So it's a cool balance between the two. But I was really fascinated with the like construction application of aerogel, but then also there's a really unique one about perfume and like smart release systems and how aerogel beads can help with that. So those are probably my top two favorite moments of the episode. How about you?
Yeah, I think it just goes back to like the basics of material science and how we know that structure can derive property and property can derive structure and process drives both of them, etc. I think it's just another great example of how using the fundamentals of material science that we learn in like our first or second years, it can lead to these incredible advances like aerogels, which it's really just about the structure. And now what can we do to change it? What properties can we do? What processing can we do? And so he tells a great story about how the first aerogel was created just from trying different processes. And so I think it's just another great example of how going back to the fundamentals of science can always help you create new technologies and advance the field, even though it may seem a little rudimentary.
For sure. And our guest, Marc, has like the R&D background, 15 years of experience, and then shifted into this co-founder and CEO role. And so that's also like another great tidbit from the episode is the like his balance between the two, and he gives really sound advice about how do you choose when you're interested in both the business development side as well as the research and development side. So really valuable episode, a lot of great insights here. And yeah, make sure to follow our podcast on your preferred podcast platform and leave us a rating and a review. It would really help us out. So without further ado, let's get into it.
Our sponsor today is Johnson Matthey. Are you a material scientist or engineer who wants to be part of the drive for a world that is healthy and cleaner, both for today and for future generations? By understanding the relationship between a material structure and its physical properties and chemical behavior, material scientists and engineers at Johnson Matthey develop sustainable technologies that are catalyzing the zero transition in transport, chemicals, and energy. They design porous materials for catalyst supports for emission control systems that remove harmful emissions produced by diesel and gasoline engines. They innovate new compositions for catalysts at the heart of the hydrogen fuel cells in trucks and buses. And they also develop new corrosion-resistant reactors for processes that enable the production of sustainable chemicals and fuels. To find out more, visit matthey.com, that's MATTHEY.com. Johnson Matthey, inspiring science, enhancing life.
Hey everyone, our guest for today's episode is Dr. Marc Fricke, CEO and co-founder of Aerogel-it. Marc is a chemist by training with 15 years of experience working for a large chemical enterprise on foam systems and aerogels. In 2021, he co-founded Aerogel-it, a company developing thermal insulation solutions that are energy efficient, that lower CO2 emissions, and that combat climate change. So we're super excited to kind of learn about your company, this world of aerogels, and hear more about your story. So thank you so much for joining us today, Marc.
Yeah, thank you for the kind invitation.
Great. Well, yeah, let's first get started with your company. It has such a unique founding story, which involves 7 different founders and lots of patents. So could you walk us through the journey of founding Aerogel-it?
Yeah, so after working in industry in the field of aerogels for 15 years, we decided to spin off the aerogel technology with all relevant patents. And for this endeavor, I asked, first of all, my industry colleague, Dirk, and then I approached 3 aerogel experts from our collaboration partner at the Technical University of Hamburg, and later 2 senior business advisors to join the strong founding team.
So I'm just curious, I guess, why 7 founders? You mentioned, I guess, like the 3 aerogel experts. Why 3 instead of 1? What was kind of the reasoning behind that founding team?
Yeah, to found a strong team, you need expertise from different angles. And from my perspective, I mean, I'm more the kind of inventor of aerogels on an industrial scale, but also have industry and business expertise. And with the co-founders from industry with different backgrounds, like, for instance, process technology and also production setup, we made sure that we combine all needed expertise in the company.
And so from previous conversations, I know that it was almost like a half split from academia and industry. What do you think are the benefits of that? And were there any downsides of having like people not coming from the same background, having issues communicating with each other like they would in industry versus academia?
So, I mean, we knew each other for more than 10 years. So that's why, I mean, I was pretty sure that I approached the right guys. And I mean, it's obvious that you need different backgrounds, business, as I said, business, scientific, but also, and this is rather important for us as we are talking about material production in the end. Therefore, you need also expertise in production technology and also process technology.
And so you started in R&D and then you went into business development. And so that might be a transition that some of our listeners take at some point in their careers. So can you elaborate on why you made that transition and how that decision affected your career?
Yeah, exactly. I started in industrial R&D. And during that time, I was involved in the development of new type of thermal insulation materials and especially aerogels. And I invented the first polyurethane aerogel with superinsulation properties. That was new. And we produced this material first in the lab and later as big slabs on pilot scale. At a certain point, the company decided to go out to the public, which was a very important decision in the end. So with an announcement and with an exhibition at different fairs. So in the end, as inventor with deep knowledge about this new type of product and also technology, I first supported business development and then took over the role while still leading the entire project as project manager. So all these different aspects and learnings helped me a lot now to set up our new company.
So I feel like there might be several companies of different sizes that utilize aerogels in various capacities. So what made you kind of decide to kind of spin off and create your own company? Was it some needs or a gap that you saw in the market, or what was kind of the reasoning behind shifting your career path?
In principle, we believe in the aerogel technology. And we also believe in the capabilities of aerogel materials to help getting, more energy efficient in different application areas, starting from building and construction, appliances, and many others. We may go into the details later. And with this unique expertise we just started at the beginning, from academia and industry, we now, feel that we have the opportunity, to really not only develop something new, but also make the difference in this discussion about energy efficiency and also clean and green technologies.
And so now moving forward, now that you've experienced the R&D and the business development and the joint role where you did both at the same time, where do you think that your career path is going to go? And do you have any advice for listeners about getting both of those experiences and then making the decision?
So what do you exactly mean by that? In which direction?
So that's a question for you, is that you've done R&D and business development, and then you said you've done both together where you led business development while also leading the project. So our question to you is, now moving forward, do you continue to plan to lead both the project and the business development, or are you going to start to choose between one or the other?
Yeah, as a CEO, I have the overall responsibility of the company, that's for sure, but I'm not so deep into R&D anymore. So my role is more or less like, comparable to the ends within the former company, where I was more responsible for marketing, sales, and business development. That's what I currently do.
And so kind of the next part of David's question, I'm just curious, is that for anybody who might be interested like me in the business side as well as the engineering side, what advice do you have for really determining which path is best for you? Is it just as simple as trying both and then just kind of going from there, or do you have any additional advice?
Yeah, starting from a scientific point of view is always useful for sure, and you can develop further and go into different directions. But whenever you identify an interesting topic, you have to persist to develop something new, go out and also display or pitch. Test your versions and adjust and so on. And don't be shy. So, there's so many platforms out now for startups, especially from university, but also for my personal side, starting a new company out of a large-scale enterprise. You get a lot of help in doing so, but you have to find your own way, as usual. So there's not this path. Please follow this, and everything is good. I think for me, one important aspect was, in addition, that I built a large network during my time at the industry along different value chains, and identify the right value chains and learn who are the key players and the decision makers. This is important. And in the end, you have to find the right partners to work with.
Yeah, even with this podcast, right? And I'm curious to get your input, but it was a whole different learning experience than kind of the traditional engineering path that I'm on, or that my full-time role is, right? Where we're tasked with learning about marketing and sales and how to build an organization from the ground up, which are all things that I'm very interested in. But I'm curious, what do you have? What are kind of the key differences in terms of those learning opportunities when it comes to starting a business versus what you might see in a traditional R&D path where you kind of climb the corporate ladder?
Yeah, you have to learn much more than of course only the scientific aspects. That's for sure. And running a business or starting a new company, the first thing for you is to decide who should be your co-founders. First of all, this is, key. The team is key, and don't start with product is searching for the right market. You need to find first market opportunities. We believe in aerogels, that's true, but we worked on this, also market development quite for some years, to be honest. And by doing so, we learned a lot about different application areas, market needs, and also customer needs. So it's always both, push and pull at the same time, and you have to find balance that within your company, but also with your partners, external partners.
Well, yeah, thanks for sharing those stories about your background experiences. You have a very valuable insight that we hope that our listeners will take a lot of value from. But now we would love to dive into your technology. And so many of our listeners have not heard about aerogels before. Could you explain what aerogels are made of and what is so special about them, and why you would even want to start a company solely dedicated to aerogels?
Yeah, aerogels are world record breaking materials. You can find them in the Guinness book, and they exhibit very high porosity, very small pores, and low densities. And if you do the preparation the right way, now you can produce superinsulation materials. And the beauty is the thermal insulation performance is better than air, even though they just contain air.
Wow.
So that's kind of a miracle, but that's the beauty behind. There's a physical effect behind called Knudsen effect. You can also look it up if you want. And the first aerogels were made of silica, meaning a mineral-based material, and still nearly all commercial aerogels are silica-based. And we were first to invent kind of a synthetic plastic-based, polyurethane-based aerogel. And now we want to be pioneering the commercialization of bio-based aerogels. So this is a new class of aerogels made of biopolymers using natural raw materials.
So what does the processing look like for this type of air-like material? We don't have to get into the nitty-gritty details, but just in general, what does that process look like to create an aerogel product?
The process behind is called sol-gel process technology. So you start from a liquid, a solution, you dissolve your raw materials in the solvent, and you do gelation. And gelation in that sense that you incorporate the solvent inside your structure you form during a cross-linking reaction of your raw materials. And after that, after forming this gel, could be particles or a slab, you need to dry this gel, meaning you have to take out the solvent by any means. The problem here is that you have to prevent shrinkage of the material during the drying process. And therefore, drying or extraction with supercritical CO2 has been established, because with supercritical CO2, you avoid surface tension, which cause capillary forces at the pores, and in the end, they are responsible for shrinkage during the drying. That's what we do. So the process technology is quite important also at the end for the final properties of the material.
And so you described it as a world record breaking material. And so when the first creation of aerogels, it's performing unlike just air, even though it's 99% air. So was the goal to create an aerogel, or do you know the story behind how aerogels were first found and created?
They were first created in the last century, in the 30s, by Kistler. And he already worked with silica aerogels. And he tried different drying methods and realized that this is key for preventing shrinkage, as like I said before, and also for the final properties. They are also called solid air or frozen type of materials, blue smoke, and there's so many.
Yeah, I remember just seeing pictures, and I thought like, oh, this is like blue smoke. So it's interesting that that was kind of one of the names for it. I'm just curious how different the process was creating aerogel from the lab scale versus all the way up to the industry scale. What was that? What were the challenges there in terms of scaling up and producing this at a mass scale?
There are a lot of challenges in scaling up. So there, I mean, you find a lot of small scale devices all over the world in different laboratories and also industrial environments, where you can produce very small scale aerogels, but to produce on large scale and also cost effective, that's a big challenge. And you have to consider each and every step, the gelation step, as well as gel formation, drying, and maybe post-treatment afterwards. So there are many steps involved, and we took a look at each and every step, and we try to optimize the different steps also in terms of energy efficiency and in the end overall material and process efficiency.
Awesome. So you mentioned this before I got a sidetrack, but a key part of your technology is making these aerogels with more sustainable materials called bioaerogels. Can you elaborate on these bioaerogels and if there's any differences other than the raw materials with more conventional aerogels?
Yeah, bioaerogels are really based on natural raw materials. This is our main focus, and these raw materials are biopolymers, usually, including, for instance, polysaccharides like cellulose or pectin, as an example. Others are lignin from wood, you may know, or you can even use proteins and make aerogels out of it, like whey protein, for instance. And usually bioaerogels are stronger and more easy to work with, not as brittle as silica aerogels. And they're easy to work with, so to speak. And our main contribution to this area so far is that we develop bio-based aerogels or bioaerogels with superinsulation performance. That's new to the world, if you wish so. And in addition, bioaerogels with low or negative carbon footprint due to the raw material offers what we say untapped decarbonization potential. That's why we say we decarbonize industries with green superinsulation is kind of our slogan.
And so when you talk about cellulose, that's commonly used in single-use plastics as like a substitute, and that could be biodegraded in a composting site with heat. And so aerogel's main use is as an insulator, which is under an intense heat. How do you get around that large problem that at least I'm seeing of being able to have such different performances? Is it really just the structure, or is there anything else that you can add to the structure to help it?
Yeah, both. First, you need the structure. You need to develop and maintain this aerogel structure for the final properties in terms of thermal insulation. And then you have to take a look at other properties like water uptake, fire resistance, molding, and so on. That's totally true. And we learned a lot during our development and also market introduction of the polyurethane aerogel, because this material works in different environments, especially in building and construction, for instance. And we know exactly what we have to do and how to develop a final product for the customers we are working with.
So could you give us an idea of, you're saying that your aerogels are decarbonization, but that's one big benefit, but the benefit would be switching it with a material that takes a lot of carbon. And so do you have any examples of the difference it is between like regular insulation or any other application with conventional materials versus your materials?
If we take a look at lignin as an example, as raw material, lignin is a byproduct of the paper and pulp industry. So during pulp or paper production, cellulose is separated from lignin, and we use this lignin as a raw material to make an aerogel out of it. So this lignin has a biogenic carbon and is CO2 negative, has a negative footprint in the end as a raw material already. And you make an aerogel out of it and also save CO2 during the application. You can increase your effect. That's why we say our customers or even their customers can decarbonize within their application areas and businesses. Mm-hmm. And so this is the carbon story. And the performance of aerogels is around about 50% better in thermal insulation properties, meaning you can reduce by half the insulation thickness. So compared to conventional foams, thermal insulation materials, the performance of aerogels is 50% better. So you can reduce the thickness by 50%, meaning 1/2, so from 10 to 5 centimeters, for instance. And even more important is to fulfill the requirements of the energy efficiency targets in the end. So you can also keep the thickness, but increase the performance to fulfill the requirements from the customers, but also from authorities.
So from that super insulation, keyword that we've touched on a few times already in this episode, is there like a critical value or like a property that we look at that aerogels kind of embody that super insulation property? I'm just wondering what applications that this super insulation kind of allows aerogels to enter and really make a difference, make an innovation in that space.
Yeah, that's a good question, and there's no sharp threshold, something like this. But I think it's accepted that a thermal conductivity value of 20 milliwatt per meter Kelvin, that's the unit. That's kind of the threshold. So everything below 20 milliwatts is called a super insulator.
Cool. And so when we talk about super insulation, you described before that it's 99% air. What does the structure of an aerogel look like to allow it to have such better insulation properties than just air, and then be underneath that super insulation point as well?
Yeah, the structure is very fine. So you can think about open porous structure with very fine struts or particles with high porosity, as you said, between 90 and 99% air, and a very high internal surface area, like a soccer field in 1 gram, for instance. So it's rather huge. And one important aspect is the density at the same time. So you have really to fine tune and fine balance all these different properties to achieve a thermal conductivity below this 20 milliwatt per meter Kelvin.
And then I've also heard, I'm not quite sure if I remember this right, but there's 3 main ways of transferring heat: conduction, which is touching; convection, which is air or fluid flowing; and then radiation. And what I believe I remember is that aerogel's unique property and why it's such a great insulator is that it removes the convectional heating properties of the material. Is that a correct statement? Or are there any other explanations as to why it's more effective than air?
I mean, there are different contributions to thermal conductivity, that's true. And in aerogels, the contribution from air conduction, so the molecules of air like nitrogen, oxygen, and CO2, the heat conduction from one molecule to another is reduced just statistically because the pore size is so small that the movement of the molecules is a little bit hindered. They're not encapsulated. Sometimes you find explanations like this. It's more like statistics, but therefore you can reduce the contribution of air conductivity drastically by 50% or even more.
Wow. So let's dive into kind of an application for where we see that structure really come into play, which is the first one is material transport. And I know I don't really think about this, but in terms of like perfumes and other liquids, transport is very important from the scientific standpoint. So can you just elaborate on the importance of this industry and how aerogel technology can potentially produce smart release systems that could revolutionize this field?
Yeah, so as I said, due to this open porous structure, aerogels can be loaded with active substances, or for instance, perfume, as you said. And the idea is to use, in our case, bioaerogel beads as a carrier for perfume, and release the perfume over a certain period of time without changing the nodes. And that's new. And one of our customers is developing a smart candle, as it's called, which, they state revolutionizes home diffuser products by doing so.
And so how reusable would it be? Say you have an aerogel and you fill it with perfume and then get it out. What is the efficiency of getting liquids out of the aerogel? And then does it lose any mechanical properties after a certain number of fills, for example?
It depends on the aerogel, but we developed new types of bio aerogels which are rather stable, and they can be loaded, kind of forever. Okay. and release the active substance. And even afterwards, it's still a bio-based product, so it can be reused or also used in other application areas.
I know you're working with partners on this, and other companies. You mentioned the smart candle, but I'm just wondering, are there any general estimates for the comparison of like the efficiency of the release, right, with a traditional candle or traditional perfume versus one that incorporates these like aerogel beads?
It's a mixture of or combination of higher efficiency. I don't have any numbers with me, but at the same time, keeping the nodes and not changing the composition over time, and just releasing top nodes, for instance. And that's the main beauty, and also the kind of the main invention.
And so we've mostly been talking about this candle, but looking for the future, where do you see the applications that you're going to work towards in the next 5 to 10 years?
Even now, we are working on different application areas and also different industries. And our main focus is energy efficiency in thermal insulation applications. And we expect the biggest impact of our materials in facade systems, in building and construction, for instance. High volumes, but also very high impact, because you can reduce the thickness of the wall and gain space, or in other words, you can keep the thickness and increase the energy efficiency. In other applications, like for instance cold chain, we also believe that we can contribute here in thermal packaging, for instance, or in refrigerators. And we know that the materials work, so we now have to integrate our materials into the systems of our customers. And one big topic right now is EV battery insulation. And it turns out that aerogel-based materials can play a significant role.
And so we've talked to a bunch of startups before, and one of the big issues is, as a startup, you can only make X amount of tons of material, and you have all these great applications where it'd be a great fit. What is Aerogel-it's philosophy on which areas to target and how to separate that X tons of material that you can make each year while you continually try to scale as fast as possible?
Yeah, we have to fine balance it and work in parallel. No? I mean, now we are planning a large scale production, and this we do in parallel with the customer projects. So depending on the customer needs, after running the projects with us, we estimate the capacity. And at the moment, we can produce in pilot lines, meaning several 100 liters per year, and we will increase step by step. But at a certain point, we have to increase, largely, and install an industrial production plant.
What did that market development timeline look like when you were just starting out, right? You said you spent years doing that. So I understand the importance of it, right? You really want to gauge the different applications, where those resources would be most valuable, where you can profit the most, et cetera, et cetera. I'm just curious, like, how did you find the right people to talk to and, gather all that data to really make an educated decision on how to best allocate those resources?
I mean, it helps a lot that I already have established a huge network globally. And in addition, right now, I mean, most of our partners, they find us, which is rather important for us because we are small and not so much visible. I mean, just a web page is not enough these days. You need at least one, but that's it. And I mean, also working on platforms, no? like LinkedIn, for instance, help to reach out. And this is true for both sides. We were found, and we can also post quite easily, and this helps a lot. On the other hand, identifying the right partners and starting projects with them is kind of the experience after so many years.
And maybe something more recent is that recently we've seen intense heat waves across the world, and especially like in Great Britain and California, for example, the energy bills are skyrocketing. And so I feel like your application will help a lot with the ever-changing climate of our Earth. How much could you just say, for example, could the energy savings be where we could save money even during these intense, like cyclical periods of intense temperature, one way or the other?
Yeah, there are different angles to look at this. I mean, it's a very complex topic for sure. But as mentioned at the beginning, so first we try to avoid CO2 emissions due to the aspect that our raw materials are bio-based. During the application time, we save also CO2 or other greenhouse gases. And whenever we contribute to energy efficiency, we might help in the sense that the energy price increase is one aspect, and on the other hand, we try to contribute. How should I explain that? In the sense that we do not offer certificates, we offer real materials to reduce CO2 emissions. And I think this is one of the main aspects.
So from the construction standpoint, which you mentioned is one of the bigger industries to make a potential impact, I'm just wondering, you mentioned kind of the wall application. So I'm just wondering, are thermal insulation and sound insulation related in any way, or are they completely different? I'm just trying to think about if you have these aerogel products in the walls, right? How does the sound, is that sound insulated, or is that easier if this is a 99% air product,
That's a good question, and we get a lot of questions like this, especially from the automotive industry, because for them, acoustic insulation is quite an important topic. And as we talked about open porous structures. Yes, the aerogels bear an effect, but due to the very small structures, they are not like a sound absorber. It's more like sound dampening. So therefore, they behave a little bit different, like traditional acoustic materials, like fibers, for instance, and open cellular foams. But they can contribute a little bit different, as I said. And I mean, for building and construction, we don't see any problems, but also not real benefits in terms of acoustic.
Yeah, so that means, right, like if that stays relatively the same, but the thermal insulation properties are significantly higher, then it's worth investing in that replacement.
That's true. Yeah.
Got it. Awesome. Well, I guess to wrap up this episode, like your story, first of all, is a great example of how someone can leverage their years of background and experience from the material science standpoint, and then shifting to become an entrepreneur and starting a company. So what advice would you have for our listeners who maybe will follow down a similar path where they have this strong material science and engineering background, but maybe one day will start a company?
Yeah, I think I tried to answer a similar question before. Like, so for me, it's like, I mean, be persistent. And whenever you identify an interesting topic, keep on going and don't be shy. In the end, what we already discussed is you need to find the right partners. You can't do it alone. It doesn't matter whether it's a small company or you want to create a big one. Without the right partners, you can forget about it. And you need this network we also touched before. And I mean, it's not like finding or just finding customers. It's important to identify the right partners, especially for these complex materials and also applications. And you also need to understand the difference in the applications and customer needs on the one hand, but also I mean, total trends, which are important, like we already discussed before.
So I think that's really great advice for how to transition, but are there any skills that you learned during your time in industry that you found extremely important in your role as CEO, other than the technical skills that you built up to understand aerogels to a point where you're comfortable starting a company?
I mean, it starts with project development, but also with like colleagues, customers, and also different type of management. So you have to find balance, but also learn hierarchy structures, flat hierarchies, learn the difference, and also deduce how you want to build up your own company, and how to run it in a smooth way with all your different partners and later employees. So employee development is important at the later stage, especially in our case. But don't forget about that. And what is also important, especially for us, is handling patents. Don't underestimate that. That's also not so easy. Write your own patents and try to deep dive into the topic, but also learn what is important to file the right patents. I mean, you get support for that, but still, I mean, if you want to understand what's going on in the landscape, especially if you start your own enterprise, that's a very important topic.
Yeah, that's very sound advice, things that I haven't thought about. So it's good to keep in my mind. So I appreciate you taking time out of your day to chat with us and really dive into the world of aerogels. So yeah, thank you so much for joining us today, Marc.
Yeah, thank you very much. It was my pleasure.
As a materials engineer, we can make an impact in nearly every single industry. But with that versatility comes a lot of different options to choose from. So if you have no idea which industry or position is right for you, believe me, you're not alone. I've been there, done that. But just for a moment, imagine narrowing down your ideal role and company by the end of this week. Imagine being able to secure your dream job offer without having to apply to hundreds of job openings. Our online course, MSE Academy, includes video testimonials, resumes, interview prep, and mentorship from materials engineers who have been in your shoes. We also connect our members with companies and industry professionals in our expansive network to help accelerate your job search as much as possible. To learn more and get started, simply click the link in the description below. And if you enroll within the next 24 hours, we'll add 3 bonus career development resources. I hope to see you there.